first. You want it first? Mine? Makanan ba?
Hi, good afternoon, everyone. My name is Sangeeta Joshi, and I would like to introduce our project. So our project name is Anywhere Anybotics Competition Team Object Detector Development, and this is our team name is Excellent One, and we are the 5 members in this team, which includes myself. There is Famsi Mansani, Rom Valley, Rakshita Shakamure, and Jessica Santa. So we come up with this name is Excellent One because the device which we are using is the Jackson TX1, and you can see there is a like kind of robot sign for the one because our project is based on robotic field. So in this presentation, we divide our project in presentation in a 7 part. So first I'm going to introduce the project. My team member will explain the system component, high level design, development architecture, database, user interface demo, where we're going to show you 2 working product. So whatever we have now, working product, we're going to show it, and we're going to talk about base plan design, progress, and the conclusion. So we are working with the team name is Anybotics. So this team is the national high school student, which they are very interested to pursue their career in STEAM. And STEAM is stand for System, Technology, Engineer, Art, and Mathematics. And so this team each year they participate. The competition name is FRC. And FRC is stand for the first robotic competition. And this team, they build the robot, and then there is other high school student, they comes and they participate and they have a competition. And this competition is the international high school student competition. So this team will be participate in 2019, and in this project, we are helping them to improve their current project. So right now, this is the current situation. So the last year they built the robot, and the last year's the computer science student for their capstone, they helped them to build this project. Where you can see this Raspberry Pi. So they use the Raspberry Pi for this project. And then for the they use the for user interface they use the FRC radar station, and where they can control, and they use also is the controller here, and this is the rover here. So this what is the current situation. So they and then about all this device, my friend Famsi will explain about everything. What is the problem and why we are helping them? So current they are using is the Raspberry Pi, and the Raspberry Pi is slower than what they want, what the expectation is. So we are using is the Jackson TX1. So you can see in here like a comparison in both. So the Jackson TX1 is the more faster and more accurate than the Raspberry Pi. So we are using is Jackson TX1 in this project. So about this, that's why we are not using the Raspberry Pi, because it's slower, and we wanted to improve and take this project in the next level. So we are using is the Jackson TX1. So about this, all these device, my friend Vamsi will talk about it.
Hello everyone. So in the system components, we have Jetson TX1. This is a supercomputer on a module. So deep learning relies heavily on the parallel processing. So Jetson TX1 can deploy 1 teraflop operations per second. It's 10 to the power 12 floating point operations in 1 second, which is very fast. So this makes it a supercomputer. And this NVIDIA has supported the QI architecture, Computer Unified Development Device Architecture, which helps the programmer to run the code to write the code on it, and they can use the code on anywhere. And using this CUDA-8, they can use massive parallel programming, which improves the performance. When we come to deep learning, performance plays a major role, as we are using this everywhere now, in the drones, in the autonomous cars. Like when a car is moving at a speed of 80 miles, it has to detect the lanes and it has to be in the lane. So it has to be like very accurate and very quick. It has to process in milliseconds. If even there is a delay of 20 milliseconds, it's gone. The car will be out of the lane. So it has to be very powerful. And this is a powerful device, so which we are using it. And we need this power in our project as well. It has Ubuntu OS on it, and it is a CPU itself. You can just plug it to any monitor and you can use the device. It's a CPU as well. And we are using Python and OpenCV for the project for this deep learning mechanism for detecting the objects, where it scans the surroundings to detect the object, and after detecting the object, it has some operations to be done. And this is RoboRio. This is the advanced version of Cerio, and this is the brain of the robot. So this has the code to direct the robot to move front, back, or any other way. So this is the one which helps the robot to do its operation. So this is RoboRio, and it has a Linux operating system. And during the previous competition, they coded it on the Java, so it runs on the Java for Java programming for the operations. So this is the driver station. So driver station is a software which has to be downloaded and installed on the PC where we are using this robot. So this has all the code for controlling the robot. You can set this to autonomous mode, manual mode, or any mode based on the requirements, and the joysticks and the other controllers will be connected. This shows what all the connected devices are, and this has software which tells the robot, which is used to send and receive the data from the controllers to the robot and from the robot to the controllers. And this shows how much power is being used and what the controller is actually saying the robot to do. So that these are the major components which we'll be using in our project, and my friend Jerry will take over like how these will be integrated together and work. Thank you.
Good afternoon, everyone. I'll introduce a high-level design and deployment architecture to you. So in this high-level design diagram, it shows how every component is configured together. First of all, we see there's an object, which is the object of this one. This object changes every year in a competition, and we will know what we have for this year until January 5th, which is the kickoff of the 2019 competition. And in the middle part is what we need to set up on the robot. First is the Jetson TX1, our processor. We will execute the Python codes on it, and we will install OpenCV on it. Also, we need to connect the Logitech camera on TX1. This camera will be the eye for the robot. Besides is the RoboRail, which controls the movement of the robot, and we will execute Java on this RoboRail. After that, we will use Ethernet cables to connect Jetson TX1 and RoboRail to the router, so they can transfer data to each other. Besides, we will need the Wi-Fi to connect the router to our client side, so our admin can give instructions and receive feedback from the robot. From the perspective of the admin, we will use a laptop with Windows operating system. We will install this FRC driver station on the Windows. This is the screenshot of the dashboard. And besides, there will be a live stream video display on the desktop, so the user can see the perspective of the robot. Besides, if necessary, the admin, the user, can use the joystick to control the robot. And at the very last, we will set up a local database with images for future the object comparison. This is our high-level design. So since this is our first phase, we decide to focus on the processor Jetson TX1. So in the architecture, I will show you how the processor TX1 works. In this use case diagram, there are two actors, admin and Jetson TX1. So admin is in charge of two use cases, boot the TX1 and stop the TX1, which are very simple. And the Jetson TX1 is in charge of the REST3, scan image, compare image, then calculate the image between the camera to the object. Based on that use case diagram, we created this activity diagram. So the scenario is Jetson TX1 identifies object and calculates the distance between the camera to the and the object. So the first admin should boot the TX1, then execute codes on the TX1. Then the TX1 takes over. So TX1 can compare the scanned image to the referenced image, then identify the target object. The last step is to calculate the distance between the target and the camera. This is the activity. So Rakshina will take over database part.
Yeah, I'm going to talk about the database, like the data storage that is mentioned in our project, where it focuses keeping it simple, like it's just the database files, flat files, which are stored in the local machine or the extended hardware, like the SD chips and the USB sticks. So it's just the flat files and it is stored in the local. And these are all of format JPEG and JPG or JPEG. These files require the fields or like name, type, size, and location or date save. These are the typical common name fields that are required for any flat file. So we chose it to be simple. And talking about the interface, like I'll show you a demo of how the Jetson works. Here are the few sample screenshots of what user interface looks like and how we can run the working on Jetson. So this is a screenshot, and I'll be demoing with the interface. So the presentation you are seeing, it's on Jetson right now. Here we have set up the Jetson, which is we booted up. It takes almost like a few seconds to boot up. And here we already set up like few test files here. So if this test case, like this test is to run and take the screenshot of particular, like it takes the screenshot, the camera is here, right here, whatever it is, it takes the screenshot of the particular situation. And we have another test here that is to be performed, like it automatically detects and provides the live streaming. As of now, like when I run, you can just see it's just live streaming whatever I'm seeing here. So this Jetson has a Tegra software, which it's involved with system on chips, and also like works on more of the machine learning and also like the computer vision. And I'm like here going back to my presentation. So this Jetson TX1 is mostly used for computer vision, drones, and many of the very machine learning systems. So this particular software needs to be successful when it has a test plan, particular like safe test plan. So we have gone through like taken in consideration like functional and non-functional testing. Like mostly this functional testing makes sure that each and functionality works properly. So it is mostly a white box testing, which focuses more on code. We included unit testing, integration testing, regression testing, and acceptance testing. Where in unit testing we are trying to plan, like we focus on each and individual method or module written in Python, either in Java, that are used to integrate the Jetson, the RoboRio. Whereas like integration testing, these units are clubbed together, are integrated together, and to integrate with RoboRio and after Jetson. So integration testing is also included in our project. Coming to the regression testing, it's very important and crucial. Like for every change that we make or every integration that we make on, the functionality should remain constant. It should not affect the functionality of the system, main system. So this regression testing is also important. In the acceptance testing, where it's just to include like how the system is exactly performing, and we also want to include our consumers who are the high school students. We also want to include them, like the end user, to perform this testing, like how the whole system works. Coming to non-functional testing, this is the black box testing, where we can just go ahead and do perform performance testing, stress testing, and usability testing. This in performance testing, we just test. The name itself suggests that it is a test for the performance of the system. So how fast the object is detected, how accurate the object is detected, and like in actual real environment, when we place a robot and after integrating the Jetson with the Roborio, how fast it can move or how fast it can detect the object. Those performances can be tested here using the performance testing. And the stress testing, this type of testing is used here in our project. It's more important because like when we have a camera screening like in a real-time environment, when we place multiple objects of same kind of object as we should see here, it should detect in such a way that it should first detect first object first, and it should continue with the multi-threading process. So this helps in stress testing. Usability testing is also we are planning to involve our end users in this usability testing. So it should like we have made sure that there is no disturbance in any of the functionalities. So it is to test how difficult the usage is, or it is test like how the end users are comfortable with it. Going on. I think it's just going on. My friend Jessica will go ahead with progress and conclusion. Just work with the mouse. It works now. Can you use it now?
Okay. Okay. So I'm going to talk about our progress and the conclusion of our project. Also, we are going to talk about future developments that can happen after this custom. So, the first thing we want to do when we come in for next month is we want to follow the agile methodology. So we will actually run some sprints to actually add some more features to our current progress, and then doing the sprints after that we will complete it that way. And also first we want to implement the codes to identify the target object, because that is the most important thing before moving on to anything else. So when we actually successfully identify the target object, we will then move on to measure the distance from the camera to the target object, and this will the calculation will be based on the focal length. Also, the next step we want to do is, as we mentioned before, we want to integrate the TX1 with the Roborio and driver station. This integration, as what Jerry said, we will use Ethernet cables to like connect the Jetson to and the Roborio to the router, and then we will use the user data agreement protocol, or UDP, so the driver station. We are going to use UDP because it's fast and it can multi-custom multiple targets. And with all this integration coming, we actually will set up as network tables. So these network tables will be our basis of security, where it actually shows all the connections between the TX1 driver station and Roborio. So the conclusion is, so our project is to upgrade from the Raspberry Pi to Jetson TX1, and this will be useful for the high school students that are competing this year. So yeah, and then we are using like some components like the TX1, Roborio, and driver station, and as well as some controller. And for diagrams, Jerry already mentioned that there are some use cases and activity diagrams. So far, we have only focused on the TX1, but into the project, we will add more use case diagrams and activity diagrams to make sure that all the components will be able to communicate to one another. And then, as Rashida already mentioned, or already shown you the demo of like the TX1 and how it looks and how it actually runs the code. Also, she already mentioned about the test plan. So far, it's still just a plan. We have not included fast cases yet, just because we have not actually run any code that will be implemented here. So, going to the future, it's like, it might be a good idea if there is a flashing light that is attached to the robot or something, to make sure that we can know that like, TX1 is functioning. So when TX1 is attached to another platform or something, like we can literally know that okay, TX1 is there. Okay. And then right now TX1 is only controlling one robot, but since it's powerful processor, it can be used for more robots maybe. So and then right now only TX1 detects one object. And it would be great if actually the driver station can detect other robots, just because it will help in preventing our robot to collide with other robots. So, good idea. And so, right now our security is based on the robot level, which is the network tables. So, it will be a good thing if there is maybe authentication system or something that can make sure this is the right person to control the robots. And right now we are only focusing to identify one target object, but in the future it can be expanded to like identifying object based on its mode, like circular or any 2D or something. And right now we are only saving the files that we for images that we can use for comparing to get the target object. But maybe later on, the TX1 can save some images to actually put into the cloud or something, and then based on that, it can be used to analyze the objects. So that's it for now.
Thank you.
Questions?
Yeah. So now, first, who did select the TX1 for you?
Dr. James.
It's not sponsored Dr. James.
Oh, so because it is hardware, and it is good that you are working on this part. It is, even if you are working on the part of programming, but you learned a lot about what it is this and the hardware architecture, and it is advanced level for like computer engineer students. So thank you for doing all these efforts. Yeah, I know it is so hard understanding this architecture. Okay, now you have two software, one in Java, one in Python. Did you select Python, or you have to use Python with this TX1? I don't have enough information in my mind about TX1. So is it up to you to select the programming
Yes.
language, or it is special for this chip?
It's up to us. We can
It's up
select
to us.
it.
You, okay,
Actually,
awesome.
the computer vision libraries are more in OpenCV, which supports most of
Python, yeah,
It
And-
is easy in using libraries of Python.
awesome.
And it has got pre-installed Python tray in it, so we don't need to install any more libraries. So it's much easier to use the libraries which we have on it,
Awesome.
which makes
And now you are working on this part. You are trying to understand. I think you are in this level, trying to understand how to select the target and how to like analyze this image and how to compare it. I think you are stopping in this after taking care about the hardware, understanding the hardware. It is so good. Go step by step, you will be fine at the end. Now the target. What are you searching for in your target now in your software goal? What is your target? Is it like a pen,
No,
it is
it's,
specific object, or this?
Yeah, right now we are doing this, but we are not sure what is gonna be in
The future.
2090 competition. So last year it was this one, so we are practice on this one.
Awesome.
But we're gonna get to know in January 5th because they gonna let us know. So then we are gonna target in the actual object which going to in a 2090 competition.
And now you are trying to write code that flexible, so in the future
Mhm.
or next month
Yes.
when they will give you the exact what they are trying
Yes,
to
you're
find,
right.
yeah.
Yes, you're right. Because the shape matters. The comparing.
Yeah.
Yes, maybe a small ball like this, maybe a big ball like this.
Maybe
or-
color
yeah.
difference, the color difference in your image, or
Yeah.
it will not affect your software, just the size.
Colors.
Yeah, the colors will be the same as highlighted object. Like it will be a bright colors of
Yes.
object. So
Easier to
Easier to
identify. Yes.
Yeah, so this is your challenge now. Okay. Do you think you need to write some code in Java for the other parts? You said you have two parts. The other parts will be fixed on the robot itself, is this
Yes.
correct?
Yeah.
And I think that part will control the robots,
Yes.
arms,
Yes.
moving,
Yeah.
whatever, according to what you are working on. So, do you think you will update this part also, or it is already one software that control arms? You will just send signals to move at this angle, or what do you think? Do you prepare yourself for this part also?
No,
Yes.
it's already pre-programmed for the Roborio. It's in working condition. We just need to improve this one to send the data to that machine. So we are not going to work on the Java
It
program
is
on
already
the
there.
other machine as well.
We're going to work on Java as
Yeah,
well.
we
So
have
we
to.
need to update whatever program is written right now. So we have to work on it too. So we're gonna work on Java as well.
Yes. Because there's another library that we have to add. Like right now we have the OpenCV library, but there is another library called WPI. I forgot the.
Watches.
Yeah, they are there on the Roborio, and we need to set the instructions to be sent from here to there. For that, we need to work on the Java, like how to send the proper instructions from here to that machine.
Share and communicate to each other.
How
Yeah,
to
yeah,
communicate.
maybe because the old device, the one that they used before, has different instructions that what you have now on the TX1. So maybe, you can try this now, if you have time before even received the actual competition subject, you can send something from your Python code to this and try it.
So we're going to do is like we're gonna interact the Java and Python. We are trying to send the file to each other. That's our plan during this vacation time.
Yeah, I think this is your next step. And I think the only challenge in your project is this image processing, how to recognize the object and how you will send it. And I think you have to make your software not complicated, to not have like time spent to execute these instructions, because as you said, the main goal is the speed up the execution time. So you have to keep, even if you have some samples, so my suggestion, when you have correct code working correctly, try to minimize
Okay.
number of instructions, the idea may be written in different way, so just focus on speed up to gain more time.
Yes, you're right.
Yeah,
Thank you.
and yeah, it is good idea, maybe it can use for multi-robots, to control multi-robots. I didn't see this architecture, and I don't know exactly what is there, but maybe you can. But I think the problem for using multi-robots, it's the signals that it will be sent. By software, we can send multi-signals, but how can distribute it between multi-robots? I think this is the challenge stuff. So if you can do it, it will be good for you. I don't know what is the restriction, what you will face there, but I think it is not computer challenge, not software challenge, it is the communication challenge. This is what I think, to have multi-robots. The title is challenge, if we have to. You have to explain the title, then it will be good. So good, I like it, and thank you for working on this part. It it is so good. Computer science student working on hardware. Even as I said, just to understand what is there, you didn't design it, but you have to understand it before going to program it. Thank you.
Thank you very much.
She did an excellent recommendation for the next step you follow. And all I could say in my comments, you performed very well, you coordinated very well. Your PowerPoint was very good, the explanation was very good, very impressive to me.
Thank you.
Thank you, sir.
What do you think, David?
There's a lot of good stuff going on, at least. There's definitely a lot in the project. I want to say that the number of goals is kind of hard to keep track of when each of you were announcing what you had at least foreseen for what you guys want to do with the project. I thought it would have been kind of nice to hear about at least just a projected idea on what procedure you guys would use for implementing your object recognition. I think that's kind of a little thing that was overlooked. You're like, okay, here's the hardware, here's how we're going to talk to each other, here's how they're going to operate in terms of the competition, and then it's going to, it's going to recognize some objects, and then it's going to, do something else. But you kind of glanced over it and it's like, wait, hold on a second. That step has like a lot involved in it, and so maybe in the future, if you could have like a slide that shows maybe like a flow chart of how you wish to implement sort of the, you need a lot of data collection for your object recognition. So maybe talk about how you're going to use your training data and your testing data to, I guess, achieve like a metric that tells you how good you are at measuring the object, or at least how far you're away from that object. That's a cool one. You should probably do that. And then who's in charge of the network routing? Just wanted to ask about that because it looked like you're going with what I was looking at the octets. It's like 192.168.0. Blah blah blah. And so that's pretty traditional for like it's like a /24 subnet, which determines like the number of devices that can go on the network. And so this is really just an extra thing. Don't worry about this. You probably are fine. It's just me being particular. But if security were ever like an issue, since this is a relatively condensed system, a limited number of devices, you could probably pick like a really weird subnet, so like a /23 or something where you don't need to support a large number of devices, while at the same time the IP addresses that are being given to the devices that are on the network are very unconventional. And so like, I don't know, it's just another little thing. You really can disregard that one. It's just a little fanciness there. And the last one was just the communication protocol between the processor and the controller on the robot. Because they're obviously within close proximity to each other, and they're both hooked up to the router, of course. But what Shata said earlier about how they would talk to each other. Did you guys have a protocol established, or at least a protocol in mind for getting the two devices? Because you're working with Java and Python. So what's what particular pipe are they going to be observing in order to establish a line of communication between the two?
We actually have no answer to that right
It's
now.
okay. Serial.
Yeah.
Look into
Yeah.
Serial. It's like absolutely universal. Most devices will have it. There's probably some boilerplate stuff, so you don't need external libraries in both Java and Python to open up the serial communication, or at least serial monitoring between the two. And that would probably be like at least a small barrier to entry when it comes to making these two things talk to each other. So I'm serious. Look into Serial and do that or at least SERIAL.
Register that.
Okay.
Yeah.
But yeah, all in all, I think just keep your efforts forward and stay organized, because there's a lot that can be distracting and probably use a lot of your time. So yeah, so far so good.
Why Serial?
I don't know. It's just what I happen to have as a preference. Yeah, I'm sorry. And it seems like most programming languages can interface with it with no issue. But it's always a matter of choice. There's other ways to go about it as well. It just depends on what you can find the most documentation on.
Thank you.
I would like to thank you and the other group who take care about testing, because not because I taught you this and you covered all subjects there. But because if we build any software or any hardware without testing, you know,
Yeah.
it will be a problem. So very good for focusing on that. Thank you so much.
Wait, last thing, I was gonna say, maybe if you guys could specify the deadline of the beginning of January regarding, how the object's like subject to change, since they're gonna do a new competition, a new game is gonna be defined. That's a big one, and then maybe also specify that the project can be a bit more exploratory in nature, rather than, like hard, set goals. It kind of gives you a little bit more flexibility in, experimenting and trying to figure out, instead of having these like, very
Fixed goals.
course, like very fixed, I don't know, like a very fixed metric for grading yourself and like, oh, you didn't do well. Instead, now you're just exploring with new technologies so that they can hopefully use them with the NUA robotics group. So I think if you could define that, you guys don't have to be as hard on yourselves.
Okay.
It gives you a little bit of wiggle room, so.
Yes,
How do you win the competition?
What?
The last one.
Yeah,
Previous
maybe I
one?
missed it, but how do you?
They make a new one every
Where
year.
is the
So
competition?
there's like new rules every year. There's new
Yeah, this
games.
is what I'm asking.
It's
Invite
typically-
us for this competition to see your device.
It is FRC competitions held every year, and it's about 5,000 people there are 5,000 members in that group, so it will be held every year in the January.
No, no,
Right,
no.
but what?
I'm assuming like
What
what
is-
we're looking at,
how do
you
you
got
win?
like a bunch of yellow boxes,
So-
and you have to put them in some region, right?
Yeah,
Yeah.
Whoever
this
does
is
the
the
most.
target location, and it will be a
Level there,
balance
yeah.
here. This is the balance of the two teams. Like there will be red team and blue team.
It's a
So,
basketball, right?
Yeah, this is the balance here. Here is the area to place the boxes, and there will be another place like similar to that side. Like it will be a balance. Who has placed the maximum boxes, that team will be going to win.
Okay,
And this team will be keeping changing like every year.
so the robot will like detect this object and will lift the object and put it there. So that's the robot will do. So whoever robot is doing the faster, it will win.
Right, so I've seen your presentation twice and I'm still unsure of what that goal is. You might want to mention that at the very beginning, hey, this is how we win or something, because otherwise you could go through the whole presentation and be thinking about what the goal of, like, what are you trying to accomplish? Trying to win this competition, which is doing this. This is how we're helping. But
Yeah.
Yeah.
that's not.
Yeah, that will be by like
January,
January 5th.
yeah.
We will be given a.
Gotcha. So
Yes.
you don't know yet.
Yeah.
Yeah.
I gotcha. Fair enough.
Thank you.
Thank you.
Excellent. Very good.
Just the HDMI.
Not that for touch.
Very good.
Oh, yeah.